Lesson 29. Lesson 29 is solving for one variable in equations with multiple variables. It's called literal equations, and we'll get that definition a little bit later. But lesson 29, we're solving for one variable in equations with multiple variables. You've done this before in some simple forms. Some of the stuff we're going to do today is really easy, and some of the stuff we're going to do today is really challenging. But what it does for you is it tests to see if you have these equation solving skills in your pockets. All right, what is algebra? It's the branch of mathematics where we learn the skills necessary to solve all types of equations, right? So when we're solving for equations in terms of another, we're going to test our ability to use the skills, right? So we're going to have multiple variables. That means we'll have variables in our answers. It's not going to be like the equations that we just solved in our Bell work where you get x equals 3, or x equals 10. We're going to get odd answers, answers that still have variables in them, right? Because you're solving equations for one to the other. It's going to test our skills, and we need to know the skills. So recall that when solving an equation with one variable, inverse operations are used to isolate the variable as shown below, right? So if you start with this equation, 2x minus 6 equals 14, first thing you do is add 6 to undo the subtraction, right? And you simplify. 14 plus 6 is 20. Then you would divide both sides by 2 to get rid of this multiplication and get the x by itself. And we get x equals 10. So our goal is to always use inverse operations to get the variable by itself. We're going to do the same thing if there's multiple variables in the equation. We're trying to get one of them by itself. All right? So let's have a look at a literal equation. Definition. It's an equation with more than one variable. Right? We're used to these, right? You guys are familiar with equations that have 3 or more variables involved, aren't you?
Is this more than one variable, like?
Yes. What's the formula for the area of a rectangle?
So,
A squared plus, wait.
area of a rectangle.
Area equals length times width. How many variables are in there?
3.
3 variables. Yes. Okay. They're all changing based on the other ones. Now we can make one the dependent and the independent. You know, we're not talking about all that kind of stuff at this point. But there's 3 variables. So this is a literal equation. Formulas are literal equations, and we're going to get to that in just a second. When you're solving literal equations, we're still going to use inverse operations and properties of equality to solve for the specific variable. What do we mean by these instructions? Solve for a specific variable. What does that mean?
How
do you solve for a variable?
You get it by itself.
Yes, you get it by itself. You isolate the variable, right? Once we have a variable by itself, we're going to have it solved. Now, to do that, we're going to use inverse operations and the properties of equality. What are the properties of equality? Not properties of equalities is good. What are the properties of equality? No. The properties of equality, these are the things that we're allowed to do to equations. So what are we allowed to do to equations?
Inverse operations.
Well,
Like
yeah.
subtraction, addition.
Yeah, we can add or subtract something from both sides. We can multiply or divide through the equation by any term we want to, except for 0. We can swap sides of the equal sign. That's the symmetric property. Okay, so all these are properties: addition, subtraction, addition, subtraction, property of equality; multiplication, division, property of equality; symmetric property, reflexive property, are the properties of equality that you've seen up to this point. Those are the things we're allowed to do to equations. Okay, so we're going to use inverse operations and the properties of equality. Properties of equality means if I subtract 2 from one side of an equation, what do I have to do to the other side? I also have to subtract 2, right? So the solution for a specific variable will be in terms of the other variables and numbers. So our solution will still have variables in it. It's not going to be like x equals 5. We're solving literal equations. Our solutions will still have variables in them. All right, so let's look at an example. Let's put some teeth to this, and you guys will know exactly what we're dealing with. In this equation, 2x plus 3y equals 10, solve for y. Y'all remember doing this now, don't you? You guys have already told me that you did this a lot last year. Yeah.
What?
She told us like once like slope because they had like a Y inside, so she
I'm
like.
kind of confused.
Right.
What are you confused about?
I don't know how to do
Okay. All right, let's go back to what all of our instructions mean. What does this solve for y mean? Means get y by itself, right? So we've got to unwrap this equation. If this was 6 plus 3y equals 10, what would you do first? Subtract 6 from both sides, but it's not a 6 there, it's 2x. So if I want to get y by itself, the first thing I need to do is subtract 2x from both sides. Okay, and that will give us 3y equals negative 2x plus 10, or you could say 10 minus 2x.
And you divide by.
Then we're going to divide everything by 3. Now, when we say both sides, if we're dividing by 3, that means we have to divide every single term in the equation by 3. Whatever I do to one term, I have to do to all the terms. So I'm going to divide this by 3. I'm going to divide this by 3. I'm going to divide this by 3.
Couldn't you just put like a giant? Could you just put them?
You can, but don't.
Why not really?
You'll see why in just a second.
Okay. Oh, okay.
Y equals negative 2/3 x plus 10 over 3. Now, what is this? That should be very familiar to you from last year.
Isn't it y equals mx?
Y equals mx plus b. So if we don't divide the original individual pieces, we're not going to get slope-intercept form.
So that's all I have to
only
do.
we're trying.
That's the only
Now,
thing
I don't know. Is that all we have to do, Brooklyn?
I don't know.
Have we solved for y?
Yes.
Is the y by itself?
Yes.
Yeah, so we're done.
Oh, okay, cool.
All right?
The only reason I
Okay.
know this is we did slope and she showed us like how to get Y by itself.
That's right. So there's a lot of times where it's very advantageous to separate the terms. Could you just divide everything by 3? Of course. Not a problem. All right. Now, if we're solving equations that have a variable on both sides of the equation, the first step is always to eliminate the variable on one side or the other, right? For example, we started off with an equation like this. What would we do?
Minus 20.
No. Always do variable first. The variable drives the ship. Always, the variable that you're interested in is what you do first. Do not start with numbers first. That's a bad habit. Can you? Is it legal? Well, of course it's legal. It's just not expedient. What did the Apostle Paul say? He said all things are lawful, but not all things are expedient. In math, it's lawful to subtract 20 first, but don't. Always do variables first. The variable you are interested in, you subtract 6x from both sides, and when you do that, you get
Something. 2x plus 20.
2x plus 20 equals 30. And then we're going to continue our quest to get the variable by itself.
Minus 20.
Now I'm going to subtract 20 from both sides. That's going to give me 2x equals 10. X equals 5. Okay? So that's the solution. That's the process, right? The first step, if your variable that you're interested in solving for is on both sides, we have to get it on one side only.
Doesn't matter which side you subtract. So I did -8 from both sides, and I still got.
That's fine. Yeah, that's fine. You solve for x. Okay? So, if we're looking for a problem like this, this says solve for p.
Okay.
Now, the problem is there's another variable in the equation.
Just great.
Step number 1, if you have a variable on both sides, the variable that you are interested in, you got to take care of that variable first. So what's the first thing we should do here?
Did you subtract P?
Subtract P from both sides.
Dang.
Shh, come on, y'all. Focus. And that will give us 3P plus 2A minus 5 equals 6A. Now, this doesn't really look any better than it looked before. But I've accomplished a major task, right? I have one variable now that has P. One expression or one term that has P in it. Before I had two, and they were on opposite sides. That's not good.
I don't like this.
All right, so what do we have to do now to get this term by itself? This is what I'm trying to get by itself next.
You subtract 2A.
Let's subtract 2A from both sides
Yeah?
and
What?
add 5 to both sides. Why not? We can do that.
Can you just make two different steps for it though?
You can.
Wait, doesn't that do 4A? Wait.
Yes, you're right. So then we will have 3P equals 4A plus 5.
Wait, hold up. Are we done now?
Nope. Is P by itself? Keep in mind,
It's not where it's, oh, I didn't do 3 on my paper.
solve for P. Brooklyn, you said earlier that means to get the P by itself, and that's exactly what we need to do. So now I have to get rid of this 3 times P. To undo multiplication, I use division. So divide every term by 3. And that gives us P equals 4/3 A plus 5/3.
Doesn't matter what you put the variable.
Yeah, that's what I put that.
Where were you going to put the variable?
With the 4, just beside the 4.
4A divided by 3? That's okay.
That's what I put, okay.
I just like to separate it out because I want to see that. All right?
And graphing, I hate graphing.
Hey guys. Why are y'all talking?
I don't really know.
We're expressing our love for equations.
Yeah, don't. It's a bad time to do that. All right, now let's go back to one of the earlier sections in this unit, and let's talk about how we might write this in function notation. Now, that's not part of this problem, but how would we write this in function notation? Here we're saying that P is dependent on, or P is a function of A, right? So we could write P as a function of A equals 4/3 A plus 5/3. We're just replacing the variable with function notation. F of A, G of A, something like that.
Instead of F, did you put P, or do we have to have the F?
No, you shouldn't use the same variable. Now, can you? Absolutely yes. You could write P of A.
Okay.
You could. It's not real kosher to do so. Okay? All right. Now, we already said a little bit earlier that area equals length times width is a literal equation. Why is it a literal equation? It has more than one variable in it, right? So we can use inverse operations to isolate any variable in any formula. All right, and I'm going to take this a step further and let you guys know that next year when you take chemistry, 9th graders, you're going to be required to isolate the variable before you substitute. So you'll be solving a lot of literal equations in chemistry. This skill is extremely important. Okay, so you're always going to use the inverse operations to isolate the variable that you're solving for first, and then make the substitution when you're using the formula. Okay, now here's an example. Y'all gonna have to hold on here because this is tough. The formula C equals 5/9 times F minus 32 expresses Celsius temperature in terms of Fahrenheit temperature. This is a literal equation because Celsius is being expressed in terms of another variable. There's more than one variable involved. Now this says find the Fahrenheit temperature. All right, what are we trying to find? F. When Celsius temperature is 20. All right, so Now, your instinct may tell you plug into 20 and solve. Would that be okay?
No, you gotta find the.
Yeah, that would be okay. You're going to get the correct answer. All right. But I'm kind of preparing you for the process that's coming a little bit later. And in the context of this lesson, what I want us to do is first take this equation and solve for F, and then substitute 20 for C. Okay? Now, the steps are the same. I'm just working with C instead of 20. Steps are going to be exactly the same. So, how would we solve this equation for F? Let's take a step back. Let's just suppose that we had 20 equals 5/9 times F minus 32. What's the first step I would do to solve that equation? We got to distribute, right? If my variable is trapped inside of parentheses, you have to distribute to get rid of it. So distribute the 5/9. Now I have an equation that has fractions in it. Let's see how our reflexes are going. How do you solve an equation that has fractions in it? You multiply the whole thing by 9 to get rid of the fractions. Yes. That gives us 9C equals 5F minus 160. And now it's a much, much simpler form to look at, right? Now next thing we would do is add 160 to both sides, and that would give us 9C plus 160 equals 5F, right? And then divide everything by 5. And that will give us F equals, I'm just going to swap sides of the equal sign. F equals 9 over 5C plus 32. Now, the third problem in your homework is going to ask you to do this process backwards. So let's talk about how we would do this to go from this back up to here. You would, to undo division by 5, what would you do? Multiply by 5, and then you'll have to subtract 160, and then you'll have to undo multiplication by 9, which means you'll divide by 9. So again, we're just practicing these inverse operations, okay? All right, now we haven't finished answering the problem because this says to find the value of F whenever C equals 20.
So then you just add 1 in?
We'll just put 20 in the place. What just happened?
Everything went away.
Everything went away.
Yeah.
I don't like that. It's still here.
Yeah, I don't know. Maybe it has something to do with the weird flash black.
That thing that popped up, kicked us out. All right, so let's see if we can do this. There, it came back.
Crap.
All right, so now we can plug in 20 in the place of C. If we plug 20 in right here in the place of C, we get F equals 9 over 5 times 20 plus 32. Right? 9 over 5 times 20. 5 goes into 20 4 times. 4 times 9 is 36 plus 32. 36 plus 32
68.
equals 68 degrees Fahrenheit. Do what? Yes. Okay, 68 degrees Fahrenheit is what we're working with here. All right? Y'all give me about. All right, so we finished that one. Let's move on to this one. the formula for the circumference of a circle is c equals 2 pi times the radius. If the circle's circumference is 24 inches, what is the radius? Okay, there's the money question, right? What is the radius? Leave the symbol pi in the answer. In other words, we're not going to make a decimal approximation and use our calculators to find a numerical value. Our answer will have pi in it. All right? Now, what is the radius? So the first thing I'm going to do is take my formula and I'm going to solve it for r. How do you solve that for r?
Can you divide that?
You divide both sides by... Oh, that won't get r by itself. Let's do that. If we divide both sides by r,
Then you get CR.
you get c over r. Does that get r by itself? No. So we need to take care of this number. Now keep in mind that 2 pi is just a number. Right? We don't know what it is, 6.28 approximately. So I'm going to divide both sides by this number, 2 pi, and that gives me radius equals, I'm going to swap sides here, radius equals circumference divided by 2 pi.
That was easy.
Well, we're not finished because we have to find the radius for a specific circumference.
Okay,
So our radius when c equals 24 is going to be 24 divided by 2 pi, which the 24 over 2 will cancel, and that's going to be 12 over pi inches. Okay? That's an awkward looking number, isn't it? Okay, now this is a little bit off the subject, but what is pi?
Is it never in the
Irrational number?
It's an irrational number, but more specifically, what is pi?
1.14159.
No, that's a decimal approximation of the number.
Not an imaginary number, it's a...
Oh, no, you're looking for like an actual, like, what's
I'm actually for
the
what is pi. Yeah,
It's a
and
number.
now we can take
It's a irrational
this,
number.
we can take this formula right here. Can't we solve it for pi? And when we solve it for pi, it'll tell us what pi equals. Pi equals, how would we solve for pi here? Divide by 2r. So pi equals the circumference divided by twice the radius. Twice the radius is the diameter. So what is pi?
The circumference.
Pi is the circumference of a circle divided by its diameter. Now that's a literal equation, and that's how pi was discovered. People who are studying circles were just doing different measurements with circles, and they discovered that if you divide the circumference of a circle by its diameter, regardless of how big it is, the same number always pops up.
That's crazy.
Okay? So circumference is equal, or pi is equal to the circumference of a circle divided by its diameter. And so they named this magical number that every circle has this property. Any circle, if the radius is a mile or if the radius is 1 inch, if you divide the circumference by the diameter of the circle, you get the same decimal value that pops up every time.
How do they get
Okay.
the name?
They just named it pi. Pi is a Greek letter. It's a Greek letter. Okay. All right. So that's the lesson. And your homework is page 174, A through D, 1 through 7, 9, 11, 15 through 17, 22 through 24, and 30.
I love it.
That's